All right, so this is the last video of the quadratics chapter, and really I don't have anything to teach you about quadratics. I just want to take a step back and look at quadratics in the big picture of what we are doing this whole year. So section 10.8, I'm going to call it comparing linear, quadratic, and exponential functions. Remember, we started the year looking at lines, right? And now we're doing quadratics. In between that, we did those exponential functions. They were the things that kind of started slowly and then took off. So our essential question for today is, what patterns differentiate quadratic, linear, and exponential functions? Like, how can I tell which one is which? What patterns do they follow, and so forth? Not just by looking at the graph, but also by looking at the points. So let's look at function 1. This is going to be my blue function. Function 1 is a couple of points, and maybe there are more in this function, I'll say, but these are just a couple. You might be able to see a pattern right now, but in order to see the patterns better, I'm just going to go ahead and put it on a table, an XY table, and I'm just going to drop the points in. So my first point, -1, 1. My second point, 0, 4. My third point, 1, 7. My fourth point, 2, 10. Sometimes having things in a table just helps. Now notice the x, it's increasing by 1 each time, right? +1, +1, +1. So the question is, what is the y doing? So for each of these functions, we need to look at the y, what's going on there, what's the pattern. That will tell us what kind of a function it is. So, okay, from 1 to 4, we're going +3. Does that happen the next time? 4 to 7, yeah, +3, and then 7 to 10, +3. Okay, so notice we have what's called like a common difference of +3. It's a common difference of +3 because to get from one y value to the next, we increase by 3. Let's look at what these points look like on a graph. -1 up 1, over 0 up 4, over 1 up 7, over 2 up 10. Oh hey, these points are in a nice straight line. So this is a linear function. The way we can tell just by looking at the table is they have a common difference. Okay? Let's look at our next function. We'll switch to, this looks cool. I like this color. Okay, so for function 2, this will be our kind of brownish or dark red function. Again, let's just kind of put these on a graph and see what happens, or put them in a table. -1, 5, 0, 2, 1, 1, 2, 2, 3, 5. Now, some of you, just by looking at these y values, are probably already noticing a pattern. There's definitely a very obvious pattern here. But let's kind of look in terms of what's being added to each y value. Because again, notice I'm increasing 1 each time in the x's, but what's happening in the y values is what I'm very interested in. So here, we're actually decreasing by 3. Is that what happens here? No, I'm only decreasing by 1. And then here I'm increasing by 1, and then here I'm increasing by 3. So what's going on here? Because I don't have a common difference anymore. But let's look at what's called the second difference. So let's look at the difference of differences. So here, to get from -3 to -1, I'm adding 2. Does that happen here as well? Yeah. Does that happen here as well? Yeah. Interesting. So even though the first difference was not in common, it looks like the second difference is in common. So this function, whatever it is, has a common second difference. Interesting. Let's graph these points. Some of you already see what's going on, but if I graph these points, 0 up 2, I see that this is a quadratic. So this is a quadratic function. Quadratic functions have a common second difference. So let's just remind ourselves of what's going on. Linear, they have a common first difference, or we can just call it a common first difference. Quadratics, they do not have a common first difference. Notice they're all different, no pun intended, but if you look at the second difference, that's the same. So quadratics they have a common second difference. Okay, let's look at our final function. Today's a pretty short video. I'm going to transfer to, let's do a forest green color. So forest green is for function 3. Again, I'm going to transfer it to a table first. X, y, -2, 1 over 8, -1, 1 over 4, 0, 1, 2, 1/2. Just transferring it into a table to give myself a little more breathing room. Now let's see what's happening with this pattern. Gosh, fraction addition is kind of hard. I know from here to here I'm adding 1, from here to here I'm adding a half, from here to here I'm adding a fourth actually, if you really know your fractions. So there's no common first difference. Let's look at the common second difference. Plus 1/2. This is also plus 1. Okay, so this doesn't help me out either. So nothing with adding is really going to do it for me. Adding doesn't seem to work. The first difference isn't in common. The second difference isn't in common. The third difference isn't going to be in common either. And there's actually kind of this cool pattern where the first difference, do you notice how it kind of becomes the second difference as well? But the point is, this is not helping me. I can't think of it in terms of addition. So let's shift our thinking entirely. Let's shift it over to multiplication. And I think you'll see here, if we think in terms of multiplication, each term, I'm definitely multiplying by 2 to get to the next one. And if you remember, this was the exponential function. We don't call this a difference because this is not a difference. We call this a common ratio. Ratios have to do with multiplying or dividing in the same way. So we call this feature a common ratio since I'm multiplying each time. Let's just graph these points. They grow very slowly and then they start to go up. Remember that with exponentials we have that asymptote here that it never crosses. So exponential functions. All right, so let's just again take stock. I'll summarize it down here for you in black because I'm in a black mood because I'm done with the video. Linear pattern, there's the common first difference. I'll write it here, or you can just think common difference. I'm adding the same thing. Quadratics, I'm not adding the same thing in the first difference, but to those first differences, I have something in common. So we call that a common second difference. The exponential pattern, I'm not adding at all, I'm actually multiplying, which means there's the common ratio. So here you're adding in the second differences, but common ratio. All right, thank you for watching. Glad I could make it short for you.